All right, the answers to the 18-1 check your understanding and the 18-1 practice. All right isosceles triangles similar, absolutely. And it's going to be by side angle side because the fact that they're isosceles means leg is equal to this leg and then this leg equal to that leg. That means that the proportions will always be equal. Because when I compare the measurement of this leg to the measurement of this leg, that ratio will be the same as this one compared to this one. So yes, and the included angle is the right angle, so they're always going to be equal. So yes, and the answer is by side angle, side similarity. Are all equilateral triangles similar? Yes, and the reason is because if they're equilateral, they're also equiangular. And if they're equiangular, then I have angle-angle similarity. Okay. Then they wanted to know, can you prove that these triangles are similar? Yes, this one's by angle-angle similarity. You've got a pair of angles here and a pair of angles here. So that means that third angle has to also be congruent. All three angles are congruent, then they're similar. The sides will be proportional. Now this one's tricky. You have a pair of vertical angles, so you do have an included angle, but you have to be sure that you write the correct proportions. So you take, what I did was I looked at this, I said, okay, I've got two different side lengths from this triangle. The 10 is smaller than the 12. So I'm going to put the 10 on top, and then I'm going to go over here and look at this triangle, and I'm going to put the smaller of the two numbers on bottom of the 10. So I made a ratio of the smaller numbers, and then I made a ratio of the bigger numbers. It's important that you get them lined up correctly. And then to check to see if they are equal, I just said 10 divided by 12.5, it gave me 0.8. 12 divided by 15 gave me 0.8, so that means they have a scale factor of 0.8. You can also cross multiply. 15 times 10 is 150. 12.5 times 12 is also 150. If you got the same number, then they're equal. They're proportional, sorry. A pair of vertical angles right here, and then this pair of angles given, that is angle-angle similarity. And this one is not anything because you do, oh goodness, I did it wrong. I just realized I did 6 over 8. I should have done 18 over 24. Actually, that's not even what I was supposed to do. I should have done 6 over 18 and then done, because those are corresponding sides. This is the smaller, 6 is smaller. Put it with the smaller number over here, and then do 8 over 24, and then see if those are, and they should be, because they're going to both reduce down. 6 will go into 18 3 times, 8 will go into 24 3 times. So they'll both reduce down to 1/3. So that one is actually side angle side similarity. We've got the proportional sides, two pair of proportional sides, and then we've got the right angles that are included. So that's side angle side similarity. Sorry. Everybody messes up. Okay, so it says, here's a picture. I tried to erase this, but if I try to erase this, then everything else gets erased. So anyway, I just gave up. What else do I need to know? Okay, well, they give me not even a pair of angles. So they give me this angle right here is 51, and I don't know the measurement of these two. And then they give me this angle right here is 39. Now, the only thing that I do know is that if you separate these two triangles, this is BCD. And if you set a big triangle, this is AO. Those should not both be named D. That's a typo. Let's change this one to E. And let's see, A, C, E. And B, C, D. Okay, so that's ACE. What you'll notice is that angle C right here is the same angle in both of those triangles. It's not congruent. I mean, it's congruent to itself, but it is the exact same angle. And what do we say when we have one figure that plays two different roles? Don't we say that it's congruent to itself by the reflexive property? So we have a pair of angles. We have angle C congruent to angle C. And if you want to put the three letters there, you can. BCD is congruent to ACE, but it's not necessary because it's the same angle. So you have angle C is congruent to angle C by reflexive property. So we have one pair of angles. We know nothing about any of the side lengths. So the easiest thing for me to do would be to try to find another pair of angles. And the only way I can find another pair of angles is to either know that this side is parallel to this side, because if those sides are parallel, then I've got corresponding angles right here, and those will be congruent. Or I could know the measure of angle C. And if I knew the measure of angle C, it kind of looks like it's 90, but if I knew the measure of angle C was 90, then I could figure out the other ones, and I could then use, then I would have angle-angle similarity, because I'd be able to calculate the measure of this angle, and it's going to be 39. If C is 90, then 90 plus 51 plus 39 gives me 180. So those are the two things that I need. I either need to know that BD is the wrong symbol. BD is parallel to AE, or I need to know the measure of angle C is 90. And either one of those pieces of information would get me to being able to use angle-angle similarity. Okay, that's the end of 18-1.